So in this video, we are going to study about the Rolle's theorem. So let's check that what we are going to study according to this theorem. So according to this theorem, first of all, whenever you have been given any function, you have to check three conditions. If the function fulfills the three conditions, then you can apply only the Rolle's theorem. So what are the conditions which are necessary before the application of Rolle's theorem to be checked? The function f is continuous on the closed interval. It means if we are going to study in a closed interval any function, then it has to be continuous in that interval. For example, look at the figure number 1. So you can see that from a till b, the function is continuous. Here also in the next figure number 2, you can see that the function is continuous. Similarly, in figure number 3, the function is continuous and it has a smooth curve. Now, second thing is f is differentiable in the open interval a and b. It means you can take the derivative of the function. So which means that you must have the smooth curve instead of the sharp turns. As you know that the function f of x equals to absolute value of x, or the function f equals to x to the power 2 by 3 or something like that. These functions, although they are continuous, but they are not differentiable. And we have studied about these things and proved that why these functions are not differentiable. So such kind of functions cannot fulfill the Rolle's theorem condition. So here in these two functions which I wrote in front of you, okay, the Rolle's theorem is not applicable. So avoid the graphs which have the sharp terms, or avoid the functions which have the sharp terms. The function, looking at the graph, you can say if the function is differentiable or not if it is bounded with it is drawn with a smooth curve. So the third condition is that the height of the first term of the closed interval must be equal to the height of the second term of the closed interval. It means f of a and f of b should have the same height, or f of a equals to f of b. So here also in figure 2 you can see that the height of a and b are same. Similarly here you can say that the height of the two terms, means the first term of the closed interval and the last term of the closed interval, are same. So if these three conditions can be fulfilled by a function, then you can say that in between, in this interval, there lie a value c where the slope of the tangent line is 0, and hence the derivative, the first derivative, is equals to 0. So here you can say that there is a relative maximum and here relative minimum. If I draw a tangent line over here, you can see that the slope of a tangent line is 0 as we get a horizontal tangent line. Same thing in number 3. If you just draw a tangent line on relative minimum, you will see that the slope is 0 because you get a horizontal line. So this is what the Rolle's theorem is. So just revise. There should be three conditions which could be fulfilled. If they could be fulfilled, then you can apply the Rolle's theorem. The first condition, that the function must be continuous in the closed interval. Second condition, the function must be differentiable in open interval. And the last condition is that f of a equals to f of b. If it is so, then in between in between A and B, there lies a C value where the derivative at that point, yani at point C, is equals to 0. Now let's check that how can we solve the question by applying the Rolle's theorem. So the first of all, you have to check that what is the domain of the function. So you can say here that this is the polynomial function, which means that the domain is all real number. So if the domain is all real number, you can conclude that the function is continuous in closed interval. Now, second condition is that the function must be differentiable. So if you take the derivative by applying the basic rule, so you will get negative 3x squared plus 4x plus 1. And if you see the domain of this derivative, it is also all real number, and hence prove that the function is differentiable in open interval. So the third condition is that f of the first term, that is -1, because this is the a and this is b, should be equals to f of 2. So for that reason, you just substitute -1 and 2 one by one in the equation. So you will get -1 whole cube plus 2 times -1 square plus -1 and -6. And similarly, just replace the 2. So negative here 2 cube plus 2 and here 2 square plus 2 minus 6. So on solving, you can say that here you will get -1. So negative you will get +1, and -1 square means +1. So you will get here also +2. And -1, -6 gives you -7. So you will get -4 as an answer. Now in the second equation, here you will get -8, and here 2 times 2 square means 4, 4 times 2, 8. So -8 and +8 cancelled out, and -6, +2 gives you -4, which means that f of -1 is equals to f of -2. So according to Rolle's theorem, then find out the C point such that the derivative at that point is equals to 0. So you have the derivative over here. Replace the x by c. So you will get -3c squared plus 4c plus 1 equals to 0. Now you can factor them. If you are using the calculator, then in case of scientific calculator, you can go to the mode 5.3, and if you are using the graphic calculator, you will go to the menu, equation, F2 and F1, and from there you will get the two values. So the C is equals to 1.54 and C equals to -0.21. So here you can see that both the values, they lie in between -1 and 2. So how can you wrap up the equation? C should lie between the terms of the closed interval, or it should be in the closed interval. So you can say that 1.54 lie, and -0.21 also lie between -1 and 2, and that would be your answer. So if you get any value of the C that is not inside the closed interval, then you are not going to write or include that C value in your answer. So have a look over here. The first thing is find out the domain, and it is a polynomial function, so the domain is all real number, and from here you can conclude that the function is continuous in closed interval. Take the derivative of the function, you will get 3x squared minus 8x and minus 1. So the function's domain is again all real number. So conclusion is that the function is differentiable. Now check the heights at x equals to -1 and at x equals to 4. So put these values one by one in the original value in the original question to get the y value. Positive 4. So here also -1 cube I forgot. Here 4 cube minus 4 and 4 is square minus 4 plus 7. So now calculate them. So you will have here -1, here -4, here you have +1. So and here +7. So 7 plus 8, 7 plus 1, 8, 8 minus 4 is 4, 4 minus 1, the answer is 3. And 4 to the power 3 means 4 times 4, 16, 16 times 4 is 64. Then here 4 times 4, 16, and 16 times 4 is also 64. So they cancelled with each other, and -4 plus 7 gives you 3. So you can say that the heights are equals to each other. So now all the three conditions are fulfilled. You can apply the Rolle's theorem, according to which you will have a certain point at C between A and B where the slope of the tangent line is 0. So just replace xc by x square and make the equation equals to 0. And after that one, just find out by factoring the equation. So again, if you are using the calculator or you are using you can use the quadratic equation also. You can factor it mentally also. So anything you can do the possible work in order to get the final answer. So your answer here, the C value, because it is not a perfect square, so you will get a C value as 2.78, and the other value you will get it as -0.1. Now again both the values lie between the closed interval, so -0.1. So both are your answers. Now what would you do if the function is rational? So of course the first thing is, in order to find the continuity, you have to find the domain of the function, according to which you will just focus on in the denominator, that is -x plus 4 should not be equals to 0, so x should not be equals to 4. So you have a domain all real number except 4. And if you check it, the 4 doesn't lie in the closed interval. It is outside the closed interval where you can find the discontinuity, because there is a discontinuity at 4. But since 4 is not lying in the closed interval, so you can say that the function is continuous in closed interval. Don't forget to use the word or write the word or mention the word in your work, closed interval. So the second thing is that you have to take the derivative and check whether it is differentiable or not. So here we can apply the quotient rule Here we can apply the quotient rule, according to which if the two functions are dividing with each other, the rule says gf prime minus fg prime over g square. So here numerator is f and the denominator is g. So start with the g, negative x plus 4, f prime. It means take the derivative, or I will show you over here. So your f is negative x square minus 2x plus 15. So the derivative of the f will be negative 2x minus 2. Your g is negative x plus 4. So your g prime is negative 1. So from here, from the right hand side, the data we will just shift on the left hand side according to the formula. So we wrote g, and now f prime means negative 2x negative 2 minus f, that means negative x square minus 2x plus 15. G prime is negative 1 over g square. It means negative x plus 4 whole square. Now open the bracket using the distributive property. Negative x times negative 2x, you will get 2x square. Negative 2x times 4, you will get negative 8x. Now negative 2 times negative x, you will get positive 2x. Then negative 2 times 4, you will get negative 8. Now minus times minus 1 gives you plus 1. So just write everything, and anything multiplied by 1 gives you the same thing. So just write down the values which are written inside the bracket, and the denominator just copy down, don't open it. Now 2x square minus x square gives you x square. Then minus 8x, and here 2x and negative 2x cancel, so you will have negative 8x. Then negative 8 plus 15 gives you positive 7 divided by negative x plus 4 whole square. Now, so take the domain of the first derivative, again the same thing, all real numbers except 4. Yani there is no change in the domain. So again 4 is not found in the closed interval, so you can conclude that the function is differentiable. Now after doing this, let me erase this. Let me erase few of the signs so that I will be able to continue on the same slide to show you that what we are doing. So after doing this, you have to find out the heights of the x at which for the coordinates of negative 5 and 3. So let's try. How can we find out? So you have to find f of negative 5 and also f of 3. So put it in the question. So negative 5 and negative outside whole square, negative 2, negative 5 plus 15 over negative and negative 5 plus 4. The second one you will get negative positive 3 square, negative 2 positive 3 plus 15 over negative 3 plus 4. So now calculate it. So here you will get 25, and so yet here is negative 25, here plus 10. So negative 15, positive 15, so you will get here 0, and here you will get negative 3 square means 9, and negative 6 you will get negative 15 positive 15, so answer is 0. So you can say that f of negative 5 is equals to f of 3, so you can apply the Rolle's theorem. Now according to the Rolle's theorem, the derivative should be equals to 0. So let me go to another slide better. So now set the equation equals to 0. Now solve for x. So if you cross multiply, the denominator will be multiplied by 0. You will get 0. So x squared minus 8x plus 7 equals to 0. If you factor it, so it will be x minus 1 and x minus 7, because 7 times 1 gives you 7 and negative 7 negative 1 gives you negative 8. So one value is x equals to 1 and one is x equals to 7. And if you remember, our close interval was negative 5 till 3. So here 7 lies, and here you can write, rather than x, you can write the c value. And even if you write x, makes no difference, but better I like to write the c value. Okay, so here 1 lies in between the close interval, whereas 7 is outside the close interval. So we will ignore 7 and we will wind up our question by showing that 1 lies in between the interval. So this is how we solve the questions related to the Rolle's theorem. So let's suppose you have a function f of x equals to absolute value of x, for example, and the closed interval is given from negative 1 till 8, for example. So the first thing is you have to see that what is the domain, and domain of this function is all real numbers. So the conclusion is that it is continuous in the given closed interval. Now, whether it is differentiable or not, you have to find out. Now, the first thing is that if you just draw the graph of absolute value of x, you know that you will get a graph like that, like V, which has a sharp turn. And if you have a sharp turn, it is already, we have studied in the previous lessons that in case of any sharp turns, the function is not differentiable. So you can just write down, sketch the graph and write down not differentiable. Now, if you want to make sure, we have studied such kind of question in lesson number 2.1 or in the definition of the derivatives. How can we solve these equations? If you remember, just to remind you, and here just first of all let me finish this question. What you are going to write, not differentiable, and hence the Rolle's theorem cannot be applied because of not differentiability of the function. So this is our answer if the function is not continuous or is not fulfilling even one of the case. Now, one more example before it. So if we have, for example, x minus 2 to the power 1 over 3 and here f of x. Again, the function is continuous. If you will see, if the function is continuous in the closed interval because its domain is all real numbers. But if you are going to graph it, you will see a graph like that. So this says that the function is not differentiable in the open interval because of this sharp turn at x equals to 2. And let's suppose here 1 till 3 is written, the closed interval. I forgot to mention it. So this is how we can not carry on, and we will say that the Rolle's theorem cannot be applied. So that is all what we have to know about the Rolle's theorem, and see you in the next video.